Hello, welcome back. Today we are going to be working on Unit 2, Constructions. Okay, on page 17, we will be copying and bisecting segments. Okay, so that's what we will be doing today. Let's turn to page 17. Okay, so our objective for today is 9:30. Perhaps it's 10:01 or 10:02, depending on when you're taking these notes. Our objective for today is to construct a perpendicular bisector. That's number one. And our second objective is to use a construction to add or subtract a segment. That's the word segment there. That's good. Okay, so we will need our blue. I believe blue is definitions, right? Let me double check. Yep, blue marker or writing utensil. So what is a construction? A construction uses a compass and straight edge to create a precise diagram. So what will you need today? You will need your compass. Should look something like this. There are a bunch of different types of compasses, but you should have one that looks like this. And you'll need a straight edge. The straight edge is literally any edge that is straight, like this one. This is a straight edge. Okay? So you need one of each. Right? The first thing we're going to do is we are going to copy a line segment. So I'm going to start by making 2 line segments. And you should make the first one about 5 or 6 or 7 boxes long. We'll call this AB. And maybe the other one you'll make, I don't know, 4 boxes long. CD. Okay. All right, so if we want to copy this, if I wanted to make another line segment the same length as AB, remember, line segment AB, that's the name of the line segment. AB with a line over it between 2 bars, or AB without the bar above means the length of the line segment. Okay. So now we're going to take and we're going to measure the length of AB. So that means we're going to put the pointy part on A, and we're going to move the pencil part to be right on top of B. And I'm going to do it really, make sure that I've got it just right. Okay, so I'm going to make another point. I'll call it E. And I'm going to draw by gently making a little arc. Now, any point on this arc is AB length away from E. Alright, so what we're going to do is we're going to take and we're going to draw from E to this arc. And that length is the same as AB because AB is the radius of this circle, of this arc that we made. Okay? So if I wanted to, that's how I copy a segment. If I wanted to add on to the segment, let's say I wanted to add on a length of CD. So let's say I wanted to find AB plus CD, and I wanted to show that length here. Well, I'd take and again measure from C to D. Carefully putting that on, making sure it's quite exact. That looks right. A little bit more maybe. Okay, and again I'd put on that point on F, and I'm using that radius CD to make another arc. And I'd align my straight edge with EF, and then I would extend EF, out to the arc, G. So A plus B is EG. Okay. Now, if I wanted to find AB minus CD, well, I just take that same arc and go the opposite direction backwards on EF. And I would mark that point, A, B, C, D, E, F, G, H. So EH is the length AB minus CD. Okay, and because there's no line above these, I'm talking about the length of these line segments. All right, so that's how we copy a line segment to add or subtract them. So now we need to just construct a perpendicular bisector. So what is a perpendicular bisector? Okay, so perpendicular bisector is a line that passes through the midpoint of a line segment and makes a 90-degree angle with the line segment. So a regular bisector is a line that only passes through the midpoint. It doesn't have to be 90 degrees. Okay, a midpoint divides a line segment into two equal parts. So we're going to construct a perpendicular bisector, a midpoint, and a regular bisector. So I'm going to start by making a line segment. I'm going to make it kind of large. I'm going to put it about halfway down my paper. And I'm going to make it, I don't know, about 9 boxes. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. 13 boxes is what I'm going to make it. I'm going to construct a perpendicular bisector. To do this, I'm going to first adjust my compass so that it extends more than halfway through AB. So it just has to go past the halfway point. So I'm going to open up my compass so the compass opens larger than halfway of AB, and I'm going to construct an arc centered at A. And I'm going to use that same radius to construct an arc centered at B. So I'm not going to change the compass. Okay. So step 1 is to construct 2 arcs with radii larger than half of AB, one centered at A, one centered at B. Then I'm going to mark the intersection of the arcs as C and D. So I'm marking the intersection of the arcs. And then I'm going to connect them. And this will make my perpendicular bisector. Okay, so here's some important points. Okay, I'm going to use purple because my red marker is currently not next to me. Okay, but you can use purple or red. So CD is a perpendicular bisector. E is a midpoint. And I'm going to make just a regular bisector. So a regular bisector is any line that passes through the midpoint here. So I'm just going to make any line that passes through the midpoint. And I'm going to make this an actual line. Okay, CD could be a line too. You could add arrows to it, but then just make sure you add arrows to your notation. I'm going to call this line M. I'm going to say line M is just bisects. M bisects AB. So CD bisects AB as well, but it has a specific name, the perpendicular bisector, because it makes that 90-degree angle. Line M bisects AB as well, and we could also write it, maybe we put 2 points on here, so there's no confusion. A, B, C, D, E, F, G. We could also call this FG bisects AB. So these are the same. Okay. So that is what a perpendicular bisector is. And the reason why this works is because this perpendicular bisector, all of the points on this line are equidistant from the endpoints A and B. So I'm going to write that over here, and that's pretty important. So all points on CD, line CD, are equidistant. That means equal distance from point A and B. So every single point on this line, so if I were to take this point right here, it's the same distance from B as it is from A. This point right here is the same distance from B as it is from A. This point right here is the same distance from B as it is from A. E is the same distance from B as it is from A. All of the points here are equidistant because all of these points can be found on circles centered at A and B with equal radii. All right, that is it. That's it. The end. Good night. Have a great weekend.